So I invest $12.95. And I look and it says compounded. As soon as I see compounded, I know it's the complex formula. 2.8, move it over twice. 0.028. I'll make that a little bit bigger. Sorry about that. Divided by quarterly. It means it happens 4 times a year. And then the time, oh, they're asking me for the time, so that's 4t. And I want to know how long is it going to take before I reach $2,000. So first thing I'll do is I'll divide by $12.95. So I'll get my calculator, 2,000 divided by $12.95, and I get 154. Put that to the side, keep it because you're going to write it as 154, but you're going to need it as a placeholder. Actually, we're probably going to have to keep that 2,000. Hold on, I'm going to have to do this because I realize I'm going to need it for that one too. So I'm going to have to change it to a fraction. So second PRB, that didn't work. Okay, second PRB turns it to a fraction, and I get, that doesn't really look, so I'll just leave it 2,000 over 12.95. So 2,000, this is kind of a mean one, over 12.95 equals. And then I'm going to simplify this. That's more important to me right now. 1 plus parenthesis 0.028 divided by 4 and parenthesis. Oops. Not doing well on this one, am I? Okay. So 1 plus parenthesis 0.028 divided by 4. And I get, oh, that one worked out perfectly. Okay, to the 4t. So I'm actually now, I'm going to go back, since that one's going to be perfect, and this one's not exact, I'm going to keep that 1.54. Sorry to be too confusing. I hope you're not too lost. So I'm going to re-put 2,000 divided by 12.95. Okay, so I get 154 placeholder, but I'm going to keep it in the calculator. Now what I need to do is log both sides. Okay, so if I log both sides, then it turns into log 1.54, knowing that I'm estimating it here, but it's perfect here, equals little, turns big, log 1.007. So now I'm going to divide by log 1.007. Now remember, this is the one in my calculator. So I have that there. So I'm going to go log of that answer, and I'm going to divide it by my perfect decimal of 1.007. And I get about 6230 that I'm writing as a placeholder. Let me show that that was the little that turned big. And now I'm going to divide by 4. And I'm going to take that answer, divide it by 4, and I get 1558. Okay? And that's my time. So let's see. It says about how long will it take. So it'll take about 16 years. Notice the difference between me saying about versus exact. Because if you look here, it says estimate. So I estimated it at 4 years. Here you see about how long. But I think there was a problem over here that I just want to know how long. If I want to know how long, you've got to give me the exact. But if I say estimate or about, that's what I want. Let's turn the page, go to the next one. Okay, the bank down the street says if I invest $12.95 compounded continuously, that's when I do that PERT. So I go base E, my rate is 0.03117. So all I have to do is plug that straight into my calculator. So I'm going to go $12.95. The E is the inverse of the natural log. So you're going to go second ln, and then parenthesis, which is what I had, 0.03 times 17. And I get 2156.55. And what are we talking about? Money. So that's how much money I'll have after 17 years. Okay. This one, write it in logarithmic form. So log 7,343 equals 3. To remind you, that's when you do this, if you don't have it memorized by now. This one doesn't have a base, so you put it in base 10. And I go 10 to the negative 4th equals 0.123. I know that I'm right because 10 to the negative fourth. I can check it in my calculator. And I can go 10 to the negative fourth, and it gives me the same thing, so I'm good. All right, let's simplify all this stuff, and then that'll be the end of that video. So adding really means multiply. So I'm going to go 4 times 16. 4 times 16 is 64. If this is 8, that has to be 8. 8 squared. Little turns big. That turns into 1, and there's my 2. Let's go to the next one. Log of 2.5, 1875 divided by 3. I can do that in my head because I know that 3 goes into 18 6 times and 3 goes into 75 25 times. So now what I'm going to do is I'm going to use my calculator and I'm going to go 2.5 to the first, 2.5 to the second, 2.5 to the third, 2.5 to the fourth. And that's it. So I'll show you. Actually, I think that's off. I think my decimal was off. Let's see. Okay, uh-oh. That one didn't work. Oops, I was thinking of something else. So it's 2.5 squared. Just kidding. I was thinking of 5. So now the little turns big, and 2 times 1 is 2. Let's try the next one. First thing, little turns big. And I can do this all in one step. If that's 2, this has got to be 2. 2 to the fourth is 16. Little turns big. And that's 1. And there's my 12. Okay. This one, little turns big. Okay. And then if I have 3, log 3, then they cancel each other. 1 times 4.52 is 4.52. Okay. Now the problem with this one is that I can't make that base be 8. So that's when I have to do that rule, the log of the big over the log of the base. And then I plug it into my calculator. Log of 32 divided by the log of 8. And I round to the nearest hundredth, 1.67. Okay? For natural logs, same thing as regular logs. When I'm going to be multiplying this. But when I multiply, it really means I add. But then my little turns big. 10 natural log of y. Let's go to the next one. In this one, little turns big. And then you have an e. They're inverses of each other, so the answer is just x to the fourth. Okay? And I know some of you think, oh, well, the little turns big, but this is a little of a little, so it stays little. And then once you make it big, it's not like you're making it big and then little again. I hope that made some sense. Okay. Log 4, I know that's 4 and it's negative, so now I'm going to go 4 to the 5th is what I think it is. I'm wrong. 4 to the 4th, and there's my 256. Little turns big, and there's my negative 4. Let's try the next one. Now, you'll notice that these two have the same base, so I can put these two together. 25 times 1 over 125. But that has a different base. So this is a different one I got to deal with at the end. So now it's a log of 1/5 and 25. Now, I know some of you are going to do it in your calculator, so I'm going to show you. 25 times 1 divided by 1 over 25. It gives me a decimal, and then I go second, PRB, and it changes it to 1/5. I think some of you knew that was the answer. So then I get 1 times 1, which is 1. But now I have to deal with this one down here. If this is 4, the base needs to be, if the base is 4, this needs to be 4. What to the power gives me 1? 0. So that's really 0 times 1, which is 0. And 1 plus 0 gives me 1. All right, let's do to the next one. So for this problem right here, little turns big. And I'm going to throw a base 10 in there. And I know that if that's a decimal, it's going to be negative, and I just count the number of times. 1, 2, 3, 4. And then 2, little turns big. and I get -8. Okay? I guess I can do the solving, and then I'll stop. In this one right here, I want to make the bases the same. 8 is the same thing as 2 cubed times 3x minus 1. 16 is the same thing as 2 to the 4th times 2x. Now that my bases are the same, I can set that equal to each other, so I'll distribute. I'll move this over here. -3 equals -x, x equals 3. Now what I do want to show you is how to check it. So what I can do to make sure that my answer is correct is I can go and literally take the 3 and plug it in. So I'm going to go 8 to the parentheses 3 times 3 minus 1, end parentheses. So that's my left side, and it has that really big value. 1677216. And then I clear it. And I take this same value and I do the same thing. 16 to the 2 times 3. And if you look, it's the same big value. So I know that I'm good to go. Okay? Let's go to the next one. The next one, the problem is here I was able to make the bases the same, but I can't do that here. So I have no choice. I have to log it. When you log it, little turns big. Log 4 equals log 400. Now remember, the goal is to solve for x, so divide by log 4. And you get x minus 2 equals, pick up my calculator, log of 400, divided by log of 4, and I get 432, which is an estimation, and then I add 2, and luckily on my calculator that wouldn't change, so I get x equals 632. Now I can show you how to check this, but it's not going to be perfect. If I check it, when I do this problem, I'm going to go 4 to the estimated answer of 6.32 minus 2. Now since it's estimated, it's going to be close to the value of 400, but not exact. So if you look, it's at 398. So unless I round it incorrectly, I know I'm good to go because that's really close to 400. Okay? I think you'll like this one the best. The bases are already the same, but it's in log form. So you're just going 5x plus 2 equals 3 minus x, small x to big X. 6x equals 1, divide by 6, x equals 1/6. Now, I can't check it by doing the logs, but what I can do is check it by plugging it in. So I could ignore the logs and just kind of focus on the 5x plus 2. So I can go 5 parentheses times 1/6 and then add 2, and I get 2.83 on the left. And then if I go 3 minus parentheses 1 divided by 6, I get the same value. So now I know that I'm good to go. All right. Quick thing, I knew there was something off. What's off is that I created an incorrect problem. So there should have only been 3 zeros here. But you would have done nothing wrong in how you explained it. Just want to acknowledge that. That's it.